In the previous video, we did some basic proofs showing how to prove that two triangles are congruent. In this video, we're going to just kick that up one notch. We're still doing basic proofs that are proving two triangles are congruent, but we are getting just slightly more advanced. Okay, it's usually good to start with the given. And in this case, we're given that angle A and angle D are right angles. So we can go ahead and mark that on the diagram like this. And we can say that the reason is given. Now, notice I have this sort of dotted line here. And this is to connect these two statements together, because some statements always occur as a pair. So whenever we say that angle A and angle D are right angles, the next thing we're going to say is that angle A is congruent to angle D. All right, so these go together side by side. And that's the reason is simply that right angles are congruent. So that's the reason you put right angles are congruent. Okay, so these go hand in hand. If you say that two angles are right angles, the next thing you're going to say is that they're congruent because right angles are congruent. All right, now, looking at the picture, we can say that BC is going to be congruent to itself because that is a shared side. But the reason you put is called the reflexive property. Okay, so this problem is not a complete proof. We're just practicing. We will get to complete proofs later on in the video. So let's keep practicing these baby steps. Okay, AB bisects angle CAD. That is given. How do I mark that in the picture? Remember that bisect means to cut in half. So, angle CAD, that's this angle right here. So this is the angle that is being cut in half. So that means that this side, this part of the angle, is congruent to this part of the angle. All right, so that's how you mark that. And in fact, the marking that we just did tells us what the next step has to be, the next statement. And again, this is a pair. When you have a segment that is bisecting an angle, the next thing you're going to say is that the two halves are congruent. So this top half here is angle DAB. So we can say angle DAB is congruent to angle CAB. Okay, and that's just the definition of angle bisector. So that's literally what we put for the reason is the definition of angle bisector. All right, that's just what it means to bisect something, is to cut it in half into two congruent parts. All right, and again, I see that we have AB is congruent to AB. So we can just mark that like that. And again, that will be the reflexive property. Okay, moving on to problem number 3. C is the midpoint of segment BE. All right, so that is clearly given. Now, how do I mark that on the picture? C is the midpoint of segment BE. Focus on the BE part for a moment. So this is segment BE right here. If C is the midpoint of that guy, that means that this side over here is congruent to this side over here. And in fact, that is what we need to put as our next statement. Segment BC is congruent to segment CE. All right? And that is just the definition of midpoint. And in fact, let me emphasize this to you. It should be fairly simple, but a lot of students mix this up. They mix up the definition of midpoint and the definition of bisector. Here's a hint. Look diagonally at the previous statement. If it says midpoint, it's probably going to be the definition of midpoint. All right, let's look at the last problem that we just did. Okay. Look at these two right here. If it says bisector, it's probably going to be definition of bisector. All right, so just look at the link between these two. All right, anyway, back to problem number 3. Okay, so in addition, we have the fact that angle ACB is congruent to angle DCE. Now, that's not given, so how do we know that's true? Well, where is this? And let me get rid of this yellow. Angle ACB is this angle right here. And angle DCE is this angle right here. Well, these are vertical angles. That's why they are congruent, because vertical angles are congruent. All right, so that's it for number 3. All right, number 4. C is the midpoint of segment AD. All right, that's given. All right. Focus on the segment AD part. Segment AD is this right here in yellow. All right, that's segment AD. So if C is the midpoint of that, that means that this side is congruent to this side. And in fact, that's what the next statement is. AC, segment AC is congruent to segment CD. All right, so these two sort of go together. As soon as you have a midpoint, that will give you two congruent sides. And the reason, again, look at the previous statement. C is the midpoint. So that's why the reason is going to be definition of midpoint, not bisector. All right, every now and then, well, I should say all too often, it'll say midpoint here, and then I'll have a student write definition of bisector. Don't be silly, all right? If it says midpoint on the previous statement, it's probably going to be the definition of midpoint for the next reason. Don't be silly. All right, and finally, we have angle ACB is congruent to angle DCE. ACB is right here, and DCE is right here. Those are vertical angles, so that's why they are congruent, because vertical angles are congruent. All right, now let's do some actual proofs. All right, C is the midpoint of segment EB. So the first statement is given. All right, when we go to mark that on the picture, it really gives us the next step. So focus on the EB part of this. All right, EB is this right here. If C is the midpoint of that, that means that this side is congruent to this side. So EC, segment EC, is congruent to segment CB. Okay? And this is going to be the definition of, guess what? The previous statement said midpoint, so it should not surprise you that this will be the definition of midpoint. All right, that's a giant clue right here. Okay. In addition, we are given that angle A and D are right angles. So we can just mark that like this. Angle A and angle D are right angles. So that was given. Now, when you have right angles, the next thing you do is you say that they are congruent. Angle A is congruent to angle D. All right, these always go as a pair. If you have the right angles, they are congruent. And that's actually the reason, because right angles are congruent. That's the reason. It's just that simple. All right, ladies and gentlemen, we are out of given. Oh, well, okay, they made it super easy by giving us the reason. Vertical angles are congruent. So where are these vertical angles of which you speak? They are right here and right here. So that is angle ACB and angle DCE. So this gives us enough information to say that the two triangles are congruent. But why? Look at one triangle at a time as you decide. So consider the yellow triangle first. What information do we have? We have two angles and a side. All right? Two angles and a side. So that means it'll either be angle, side angle, or it'll be angle, side. These are the two options that have two angles and a side. It'll be angle, side angle if the side is between the two angles. It'll be angle, side if the side is not between. Okay? This side is not between the two angles. So that's going to make this angle, side. All right? If you have any trouble seeing why this side is not between the two angles, go ahead and put a dot on the first angle, put a dot on the second angle. If you connect those dots, it shows you the side that is between those two angles. And notice that is not the side that's marked. All right, now we need to go ahead and make the congruence statement. Triangle ABC is congruent to triangle what? Well, angle A corresponds clearly with angle D, the other right angle. What about angle B? Angle B is the one blank angle, so it's going to correspond with angle E, which is also blank. That leaves angle C, and the yellow C and the white C are both congruent. So that's it for number 5. All right, last one, last proof. AB, segment AB is congruent to segment DB. That is given. All right, let's mark it. Segment AB is congruent to segment DB. Okay. Segment CB bisects angle ABD. Okay, that is given, so that part is easy. We need to mark that in the picture somehow. And in fact, by marking this in the picture, it will actually give us the other half, the next statement. Start with angle ABD though. ABD is this angle right here. ABD. That is angle ABD. Bisect means cut in half. All right, so if we cut this angle in half, that means that this half is going to equal this half. All right, so that's what we put for the next statement. Angle ABC is congruent to angle DBC. All right, now for the reason, it's going to be the definition of what? Look at the previous statement. See how it says bisect? This is going to be the definition of angle bisector. All right. What else? Well, they gave us this big hint that the next reason is going to be reflexive property, but we would have looked for that anyway. The shared side will always be congruent. So we will say that CB, segment CB, is congruent to segment CB, and of course that is the reflexive property. Now this should be enough information for us to prove that the triangles are congruent. Now, which one of those properties are we going to use? If you look at one triangle at a time, so let's color this triangle yellow for a minute. Okay, what information do we have in this yellow triangle? We have two sides and an angle. Technically, when you have two sides and an angle, there are three possible things that could be happening. It could be side angle side, all right, that's two sides and an angle, or it could be hypotenuse leg, or it could be a side-side angle situation. Side-side angle doesn't actually prove that triangles are congruent. So in this case, we're proving that triangles are congruent, so it can't be this one. Hypotenuse leg is only for right triangles. All right, only a right triangle has a hypotenuse. We don't know that these are right triangles, so it can't be that one. So it really has to be side angle side. And that makes sense because also the angle has to be between the two sides. And you can see that this angle B is between the two marked sides. So it does make sense. All right, so let's go ahead and make the congruence statement. Triangle ABC is congruent to triangle what? All right, well, angle A clearly corresponds with angle D. All right, it's pretty obvious the way they're opposite from each other like this. Now, how about angle B? Look at the single mark here. Angle B is the yellow angle B is congruent to the white angle B. All right, so angle B corresponds with angle B. Similarly, the yellow angle C is going to be congruent to the white angle C. Notice that they are both blank. And that is how you prove that triangles are congruent.